I'm gonna go mute my video so then I can go off and run to and be back. So I'll check in about 2 minutes, I guess.
Hey everybody, we'll be starting in just a few minutes. We're waiting for a few more people to join, but it looks like a good crowd. All right, so hang in there. We'll start in a few. Hey, everybody. We'll just give it 1 or 2 more minutes and then we'll get started. Please use the chat if you're having any technical difficulties, and we'll see if we can figure that out. We'll start in about 2 more minutes. Okay, so I think we're going to get started. This is the webinar on how to electrify an Eichler. If you weren't expecting that, you're in the wrong webinar. This is sponsored by the Green Meadow Community Association and the City of Palo Alto. It looks like we have a great audience, so I'm excited. We have a lot to talk about today. So the first thing I want to do is, admit this person. I want to introduce our speakers. So speakers, if you are not showing your video, you might want to show your video so people can see you. So we have two folks from the city, Tony and Scott, who are joining us. Tony is an energy auditor for the Home Efficiency Genie. He's seen many of our Iclers and knows a lot about them. Scott is a program manager for the city. He has worked with the Genie. He knows a lot about things like water heaters. So he's going to be talking about that. John Gross is here. I'm not sure you can see him right now, but he's our hydronic specialist. Hopefully he can answer a lot of questions about heating. Dennis and Olivier are Eichler owners, and they have done some electrification. And so they're going to talk a little bit about their stories and what they've done and what's worked and what hasn't worked. And my name is Sherry, and I will be the host of this webinar. A couple of logistics. If you guys have questions, feel free to use the chat. I don't know that we're going to be able to get to all the questions, but at least we'll see them and we'll know what you're thinking and things like that. Also, this webinar is being recorded. So if you would like a link to the recording or you would like a link to the presentations, we don't have your emails because we didn't require registration, but you can email info@greenmeadow.org and we can follow up with whatever information you want. Okay, so before we go on, I want to do a poll of the audience just to get an idea of where you guys are in terms of electrification. So you should see a poll on your screen now, and just select the kind of things, what have you adopted so far? We'll give this about, I don't know, 20 or 30 seconds. I'll share the results with you when you're done. No, it's kind of interesting. Okay, how about 10 more seconds? Okay, I'm going to end the polling now, and I'm going to share out the results. So hopefully you can see the results now. It looks like there's a winner. This wasn't supposed to be a winner or loser kind of thing, but a lot of you have EVs and foam roofs. One home battery. So interesting. There's a variety of people. Some people even have a heat pump space heater. So we've got a variety of levels of sophistication, I would say. Okay, moving on. Okay, so We had a pre-webinar survey and we got a lot of good questions from you guys. One of the questions was, how much do I have to worry about my home emissions? Is that a big part of my footprint? The answer to that is it depends. So it depends on what kind of car you drive, how much you drive it, what your diet consists of, how much you fly in airplanes, how big your home is, and things like that. Now, the footprint shown here is for what could be an average Eichler owner. So this is the average amount of gas that homes in Palo Alto use. It's for somebody driving a 2016 Prius, an average number of miles, about 12,000 a year. It's for somebody, this person flies once a year to London and once a year to New York, and they eat kind of a low meat diet. But anyway, I would encourage you to go look at carbonfootprint.com and learn about your own footprint. But I do think that it would be common for building emissions to be around 20% of your footprint. Okay, so again, in the pre-webinar survey, we asked what you wanted to hear about. So most of you wanted to hear about hot water heating and radiant heating. So we're going to spend a lot of time talking about that. We'll also be talking some about solar roofs and efficiency. Now, efficiency we're talking about because it's really important if you are going to do efficient heating to not oversize your system and not spend a whole ton of money on bills. So we're going to spend some time on efficiency, and then space cooling will go along with the space heating. You'll note a couple things. One is that we're not talking a lot about stoves and dryers. Partly there wasn't much interest, and partly they don't contribute a lot to your footprint. So, and we're not talking about EVs. Now, EVs are super important for reducing your carbon footprint, but it's not related to owning an Iclear. So we're just not talking about that right now. But anyway, hopefully we're spending time where you want. The agenda looks pretty much as you might expect. Tony is going to talk about efficiency. We're going to hear a real life electrification story from Dennis. Scott is going to talk about water heaters and then also touch on electric panels a little bit. I'm going to talk about solar roofs, and I will also touch on power outages and batteries a little bit. And then John, we're going to have a big long session with John about space heating and space cooling, and hopefully some time for some Q&A. There's going to be a lot to take in, but I hope that, one sense that you get is all of you could probably have your emissions by doing some efficiency work. It's fairly straightforward stuff. Some efficiency work, maybe a heat pump water heater, and if you wanted, add one mini split to a room to offload your radiant heat and get some heating and cooling in that room. That would be one example of something you can do that's not super complicated. So I think this is it. So now we're going to move on to Tony. Tony, are you ready to go? All right.
I'm ready. All right, so efficiency. Apparently it's not the most interesting subject for tonight, but the key thing to understand about efficiency is reducing your energy footprint. What do you need to keep you comfortable, keep your home lights on and everything? That if you think about it, whether you electrify now, electrify down the road, still have gas boiler heating, if you can reduce the total amount of energy you use, that means down the road, whatever you change to or when you transition, you're just going to use less energy overall, especially if it's a gas burning appliance. So efficiency is really a key step. Reduce before you produce, or other things. For that is one mantra I've used. So I just listed a range of efficiency things that might be something to consider for Eichler homes on what could be some paths for efficiency for you, whether you electrify or just want to make your house more comfortable or more efficient with what you have already. So the first one at the top is a foam roof with rigid foam. That's perhaps one of the more complicated ones to do, but it does have the biggest impact for efficiency of Eichlers, mainly because, as you know, Eichlers, there's no crawl space, there's no traditional attic, it's a flat roof. And knowing where warm air goes, warm air rises up. You want to be able to keep as much energy in your home as possible. So since warm air rises up, the best place is at the top. So when I talk about rigid roof is literally you're stripping the roof down to its base layer and you're putting rigid foam insulation before you re-roof on top. It's one of the most costly ways of doing it. It's more challenging because you're literally taking your roof down back to the base layer. But when you build up with rigid foam, this will get you the most insulation R value and the best results for that. So that is like the premium cost is not an issue, best way to make efficiency improvements for Eichler homes. Sort of halfway in between is spray foam. So you're adding a foam layer on top of your existing roof. It works, it adds 1 or 2 inches, but doesn't add the 3 to 4 or 5 inches that you need with rigid foam. So it helps, it's sort of halfway in between, but there are challenges like maintenance of a foam roof. Every 5 years, you got to maintain maintenance. So there's a maintenance issue, whereas if you take it down to the base and build from a rigid foam, it'll last longer than this sort of intermediate solution. But it is more budget friendly because everyone has to maintain their roof. So whether you go all the way down to the base with a rigid foam or you do a spray foam as sort of an intermediate, that's one of the biggest ways to make your home more comfortable. Wall insulation, it could help, but as we know, total wall area is the smallest part of an Iclear. So those rooms that have mostly walls could benefit, but the rooms that are mostly windows, they're not going to get a benefit from wall insulation. Something that could help with comfort and efficiency is window shades. If you don't have awnings in every part of the roof, window shades could be a way of keeping heat in, keeping some heat out for that when used strategically. So based on the type of window shades you pick, cellular shades, honeycombs, it could be costly. So it's sort of in the middle for that. I'll tell you right now, putting in double glazed, dual pane windows, it's very expensive. The return, it's sort of in the middle, but it's easy to do, but it's expensive. I would recommend it probably consider more the roof than the glass in many cases, but depends on the conditions of your windows. Like I said, each home is a little different. 2 simple things you could consider: a smart thermostat. So you can have your radiant heating system or whatever heating system you have better controlled and managed remotely. Can be a way of saving energy, and it's a very simple thing to put in. Programming might take a little practice at first, but it's a very simple way of, for low cost, potentially have a good impact based on your heating needs. Sealing air leaks. Iclears are not too leaky from my testing of homes, of Eichler homes. They don't leak a whole lot of air, but there are places where they leak air, especially those that have grooves in your roof. There are air leaks to all those if you didn't realize that. So some minimal air sealing of the high points will help with keeping the warm air in your home. So simple things to do, and moderate impact for low cost. Next time you're painting, that's the time to air seal. And then of course, if you have a chimney that doesn't have a damper, definitely look at a chimney pillow to prevent that hole from losing any energy through that. So that's sort of a list of most efficiency options that are done with a lot of Eichlers for that. It just depends on your budget, your actual house age and conditions for that. Next slide, please. All right, so for your home, each home is unique and different. If you want more advice, please reach out to the Palo Alto Home Efficiency Genie program. You can reach us at efficiencygenie.com. This is a service paid for by the city for you, so it's free, independent advice. If you want to call us, the number is 650-713-3411. I'll put that in the chat box at the end. Free to call, get advice, have a discussion. If you feel you need more input, you want us to see what's going on in your home, you can arrange for a virtual assessment where I would actually be visiting your home via a conference call type and be able to walk through, look at your equipment, look at your panels, give you a very rough idea of what your home is capable of and what the things to consider as the next step. If you really want some advice, have some discussions, this is sort of a free way to talk about advice. If you want a virtual visit, that's available for $49 from the program. And with that, I'm done with my section, I believe.
Tony, thank you. We did get one question. Is the Genie only for Palo Alto?
For the Genie services, yes. But outside of Palo Alto, I'll put in a link to those who are PG&E customers of an advisor service that's somewhat similar, but not quite the same as Palo Alto. And they have a utility rebate program for PG&E customers. So I'll put that in the chat box for that person.
Okay, super. Thanks, Tony. Dennis, you're up. Are you ready? Dennis, I think you need to unmute. There you go.
Okay, thanks, Sherry. My story begins in 2015 when I bought a Tesla and I got solar panels on the roof. So there's the solar panels. It's a sun power system, 3.9 kilowatts. There's 12 panels. And the roof you can see is slightly tilted, unfortunately, in the direction of southwest. So it's a perfect orientation. I did have to upgrade the main service panel from 100 to 200 amps. And I think somebody's going to talk about that later. That's on the next slide. And you can see the panel is on the left, the big panel. And the other stuff there is the electrical equipment for the solar panels. And then also ran a line 240 volts into the garage to charge the car. So that's the next slide. And all the wiring runs across the roof. This system produces about 5,500 kilowatt hours a year. And for me, because I did it almost 6 years ago, it's my payback is about 20 years. Today, you can get the same system I have for considerably less than half of what I paid, and your payback would be much shorter. Then in 2019, the city offered rebates up to $1,500 for converting a gas water heater to a heat pump water heater. So I did that. And there's the tank for the water heater that's in the garage, in the closet in the garage where the old gas heater was. But the heat pump is outside, which is the heat pump shown in the next slide. This is a Sanden 83 system. The wiring and the refrigerant lines run across the roof for this as well. And so then I kept on going and got a electric boiler for the radiant system. It took out the gas boiler. That's shown in the next slide. And it's tankless, obviously. So then I went through the winter of 2019, 2020 with this, and it was not heating the house. I had to use space heaters in addition to the radiant. There's actually no radiant left in the floor in my house. That's all corroded away, and they're all baseboard radiators. So this is a 14.4 kilowatt electric boiler, which converts to 50,000 BTU. The gas boiler that was taken out was 300,000 BTU. So that's part of the reason why it's not adequate. So my solution to that is to look for a heat pump mini split system with a radiator in each bedroom and one in the living room and one in the family room. And the heat pump would be in the backyard up on the back of the house. So in the winter, I spent with this heater, my monthly electricity usage went up from 600 kilowatt hours with the gas radiant to 1,800 kilowatt hours for the 4 winter months on average. The heat pump system can cool as well as heat the house. And then a year ago, I replaced my gas cooktop with an induction unit, which I think is a much, thank you, a much better way to cook. No precise temperature control, there's no open flame, and there's no pollutants from the combustion of natural gas in the indoor air. So my plan is this summer, after I've been vaccinated, to get the heat pump mini split heating system put in, take that through next winter, and get a measure of how much electricity it uses, and then upgrade the solar system to produce that on to match it on an annual basis. And that's my story. Thank you very much.
Hey, Dennis, thanks. That was really interesting. I hope people get a sense from that, some things are possible and very easy. Some things need a little bit more thought. I expect that our hydronics guy, John, was listening to that going, oh my gosh, I could fix that. So one of the things that we'll talk about with John are what are some common mistakes that people make and how do you avoid those and how do you size these systems and think about that. Anyway, thanks very much, Dennis. So now we're going to talk about hot water heating, and Scott is going to cover that. Scott, are you on?
Yes, thank you.
Okay, awesome.
Okay, Sherry, actually, can you advance to the next slide with the other one more? Yep. Great, thank you. So a typical gas water heater accounts for almost 40% of your annual gas usage. Typically a heat pump water heater looks very much like your existing gas tank water heater, but actually has a small compressor on the top. Dennis actually has a little different model where his is actually the compressor is located outside, but typically this is what you'll see is one where the compressor is located on the top. Just a real quick explanation, a heat pump is really similar to your refrigerator, but it works in reverse. So for those of you who aren't familiar with the technology, essentially it uses a refrigerant to capture heat in the air and move that heat to the water. So they do need air around them. So typically garages will work well, but also outside facing closets. If they have a well-louvered door, those will also work. You can use an internal closet, but it will work best when it's well vented to the outside. And they are very well suited for our Bay Area climate. They're very efficient. They're about 300% efficient, meaning that for every unit of electricity consumed, 3 units of hot water are produced. And often heat pump water heaters are called hybrids. And I just want to make sure that people understand that term. It's basically a combination of a heat pump and an electric resistance coil. So it's not really a hybrid like a car where it's using electricity and gas. So the cost of a heat pump water heater, generally the unit costs around $1,500 or less. Some are even available for around $1,000. Although the average cost for an entire heat pump water project is typically, at least in Palo Alto, about $4,500. And that's from information we've collected from about 60 projects that have been completed in the city, like Dennis's who've applied for a rebate. So oftentimes labor is the significant portion of the project, and that's because we're having 2 trades involved. So typically if you just get a water heater replaced, it's just a plumber, but in this case you have electrical work or an electrician and plumbing work. So one of the takeaways is it's important to get estimates, to shop around, to find out what opportunities there are and who to find that might work best for that. And I'll talk a little bit about that in a few slides. So the City of Palo Alto Utilities offers a generous rebate incentive that Dennis mentioned. It is based on the size of your unit. So a $1,200 rebate is for up to 79 gallons and $1,500 rebate for 80 gallons and up. In addition to that, there is a federal tax credit of $300. So there's these opportunities, and these may not last forever, but they're definitely ways to make the cost of the heat pump water heater more affordable. One of the things that is slightly different from gas is the sizes are slightly different. So 50 gallon, 65 gallon, and 80 gallon are some of the standard sizes. Also, They come in different amperages. There's a 15 amp and even a 30 amp model. We'll talk a little bit about that more in the panel discussion, but that can be some of the consideration for what size you're going to use. But what also makes these interesting are some of these great features they have. So they have modes for their use. One of them is an energy saver mode. So as I described, these are oftentimes hybrid. So they have both electric resistance and heat pumps. But when you put it in the energy saver mode, it'll focus mostly on the heat pump side. And so, using the most efficient energy consumption possible. You can also put it on vacation mode. You can also put it on a high demand mode. So if you have guests visiting, you're worried about the consumption levels being higher, you can turn that up to make sure that you have adequate water supply. Another component is they are often now Wi-Fi connected. So that means you can monitor your system from either your phone or from another device. Often they have leak detection systems with auto shutoffs, which is another great feature. Oftentimes water heaters don't give you enough warning and they'll continue to run even though they have a leak. One of the other great aspects of the connectivity and the monitoring is you can also set up timing. So it'll run when your solar PV output is at its highest. So during the middle of the day, when, not that we have time of use in Palo Alto yet, but you can essentially store your photovoltaic energy in the form of hot water. It almost acts like a battery. Next slide. So a couple of things. One is the resources that are available. So the City of Palo Alto Utilities has a really great heat pump water heater website. It's cityofpaloalto.org/HPWH for heat pump water heater. It's a great resource. There's rebate info on that, a great contractor list. There's lots of other resources and some FAQs. So it was one of the takeaways from tonight. If you're interested in a heat pump water heater, for sure go to that resource. So one of the other important parts of a heat pump water heater project is planning ahead. So Dennis described this too. You need a separate circuit, and typically they're 240 volts. So you'll likely need an electric circuit now to your water heater location because in the past you've only had a gas line running to that. So you want to plan to have this done to prepare for your heat pump water heater installation. And oftentimes the gas water heaters don't give you warning that they're failing. So you don't want to get caught with a failed water heater and then not enough time to do this. And gas tanks typically last about 10 to 12 years. So it's important to be proactive. Look and see what the age of your unit is. If you need help with that, actually the Home Efficiency Genie can give you advice on finding the age of your unit. The other component is that plumbers, especially plumbers who are not familiar with heat pump water heaters, might not have them on their truck. They're typically used to doing projects where it's a quick swap for like, and they may not have what you're looking for. If you want to get the model you're interested in and be able to do the research, it's important to do this sort of beforehand. And if you go to the heat pump water heater website, we have a list of contractors. So a good way to get started is to reach out to those contractors and get some estimates and just talk to them about your project. So for sizing, you will want to oftentimes upsize slightly from your existing water heater. So 5 to 10 gallons is sort of typical. The sizes I described before. So a 40-gallon tank now, you might want to go up to a 50. They also have a 65, but oftentimes a 75-gallon might go to 80-gallon. And it's just because they have a longer recovery time. So people want to make sure that they have enough capacity. But there's actually another component to capacity, and that's to add what's called a mixing valve. Many of them already come with them installed. With the mixing valve, a typical water heater temperature is 120 degrees, and that's actually for safety. But the water heaters can actually generate higher temperatures. But to make sure that that's safe, you need a valve to basically merge some of that higher 140-degree temperature water or even higher with the water to make it safe to use at 120 degrees. But essentially you have a larger capacity then because you now have this hotter water available. I also mentioned earlier a 15 amp model is available, and that might be helpful if you have a limited amount of space on your panel. I'll talk a little bit more about that in the panel upgrade section, but this may be an important component in not having to do your panel upgrade. So coming soon, actually, it's pretty exciting. There are actually 120 volt models. They're probably going to be coming out this spring. I just heard from some conversations in a meeting today that there's maybe 3 manufacturers going to be coming out with models of 120 volts. So that'll be really easier for your upgrade because you may not have to be as involved in electrical panel capacity. The other component of that is with a 110 volt, you know, you'll still have to run a dedicated line, but it may not impact your panel as much. So this is a great, it's really a great opportunity. And so maybe easier to upgrade. The one difference is that these do not run on electric resistance. So you don't have that capability of what we call the hybrid before. So you can use electric resistance. They'll really run only on heat pump. But if you're really managing your water usage very well, they shouldn't be a problem. Like I said, they can definitely keep up in our climate. Next slide. And so a little bit about electrical panels, and there's some images here. So all of the electric power for your home comes from the city's electrical connection, and it goes through your meter and it goes to these electrical panels. And this is basically your home's electrical wiring. It meets in a series of circuits, and those are connected to breakers, which you can see are those black switches. They're actually safety switches to make sure that there's a problem that they shut off automatically. But you can see from like the older to the newer ones, the sequence is sort of like the oldest on the left. It's just the number of physical circuits. So there's quite a bit less on those older panels. So you may not have the ability to be able to upgrade. Eichlers and most homes built in the 50s and 60s and even later, a traditional panel is really only 100 amps. And that was mostly adequate at the time. And although today, some of your electric circuits are actually lower. So one of the things that's now lower is lighting, because LEDs have given us some additional capacity. Incandescent bulbs of the past use about 5 times more energy. So we've got a little bit of electricity we can use from our electric lighting. However, there's a lot of higher draws. One of them is kitchens. They're definitely drawing more amps than they were in the past. Of course, people now are interested in EV charging and heat pumps and other systems. So it's really important to really look at what your future needs are. So you may need more capacity. So we really want people to think about their future electric needs, not just the current electric needs. So, you know, I've been discussing heat pump water heaters, but as Dennis has described, you know, it's a journey. And so he's wanted to do things along the way. And maybe you want to add an electric vehicle charger, or maybe you'll add a second vehicle charger. Maybe you want to add heat pump space heating and cooling. You may want to add induction cooking and replace your gas cooktop, like Dennis said, for health and safety reasons. Even an electric clothes dryer to replace your gas dryer. So there's a lot of considerations, and these things are all components in what you might want to do in preparing for future of an electrification, and not just doing one appliance, but maybe doing a future of appliances. From the information that Sherry had gathered, I think most of the people who responded to this said that their home had been upgraded to a 200 amp panel. So that's really great. You'll probably be fine. You can probably do a lot of upgrades with a 200 amp panel, and especially if you're doing these with a professional who knows how to, you know, use those amps well. I do want to touch a little bit on the cost to upgrade a panel. These do really vary widely, and so even though I put, you know, $1,500 to $3,000, that's sort of the ballpark range. Dennis or Olivier or somebody else might talk about those prices, what they've seen, but it does vary, and it can vary based on, you know, where the panel is, if you have to move it, or if you're bringing in new wires from the city. Couple points. Tony touched on this briefly, but I do want to mention that there is the Genie Home Electrification Readiness Assessment, often called the HURA, and that's where the technician can really help you evaluate your panel. And it's a calculating tool. Will give you sort of electrification options, and then we can plug in different scenarios. If you want to plug in 2 or 3 different scenarios, we can kind of give you an idea what your existing panel can handle. So that's a really great opportunity. Really just reaching out to an electrician and finding out, you know, from a local electrician who has worked in Palo Alto, what your options are and getting some price on that. And then in the very bottom, there is there's a link. The city of Palo Alto has a electrification webpage. I know in a future slide, Sherry has that up as a resource, but as a sub slide of that, or sorry, as a sub page of that is electric panel upgrade webpage, which has some resources specifically on electric panel upgrades. So there's some great resources. Feel free to reach out to the Genie, reach out to us. We're happy to try and help along this journey. And I think that's it for me.
Scott, thanks a lot. In Green Meadow, the originals were 60 amps. So the neighbor across the street from me has something like 7 switches, different colors. It doesn't even look like this. It's crazy. Yeah.
Yeah, those early ones, yeah, will definitely probably need upgrading.
Yeah.
There's also some safety requirements with all that too, is modern panels are safer. There are also, and I just dropped this in real quick, there are something called smart panels, which are better at allocating the use of the electricity that's in your panel. So we could do a whole subject on that, but that's something else to consider as well.
All right, so thank you, Scott. So I'm going to spend a few minutes talking about rooftop solar. So one thing that's everybody should understand is that rooftop solar does not directly help reduce your emissions. Because we live in Palo Alto, the electricity we get is carbon neutral and even almost on a time coincident basis. So for 2019, you can see a picture here. It was about 2/3 hydroelectric and then a bunch of other stuff. 2020 is probably going to be less hydro because it was a lower water year and more solar, more wind. But our electricity mix from Palo Alto is good. But you'll see that a lot of people have solar. And so why is that? So the main reason, I think there are 2 main reasons. One is it can save you money on electric bills. And maybe your electric bill isn't that high now, but if you do go all electric as a house, it will double. It may more than double, depending on what you do. So that's one reason. If you're preparing for really going all electric, it's fine to add a heat pump water heater. You're not going to notice it that much. Or even an EV. I think a lot of you have EVs. You don't notice it that much. Plus, it's a lot cheaper than gas anyway. But space heating is a pretty big hit. So some people consider it in that vein. Some people think, well, it improves resilience, and they're worried about power outages. If you get a battery, it helps with resilience. There are some cautions. It does take time to break even on this stuff, especially if you buy it outright. With a loan, it takes maybe 5 years. But if you buy it all up front, it's going to take much longer than that, maybe 15 years to break even. You also need a newish roof before you put the solar panels up. That can cost more, and you need a decent electrical panel. So those things can make a difference. With Eichlers in particular, it encumbers the roof. So if you later on want to put conduit on your roof, or you want to put plumbing on your roof, it's going to be more difficult if you have solar panels there. And finally, something to be aware of is there is a tax credit for solar, but it could expire after 2022. It's pretty big. I think it's 26%. And if you do your panel at the same time, your panel also gets that discount. If you do a battery at the same time, your battery also gets that discount, but that may go away in 2 years. So this is stuff to think about if you're considering solar. I'm going to show you a link that's on the Palo Alto's website, which will help you go over various options for yourself. For example, whether you buy it up front, whether you loan, whether you lease, what the trade-offs there are. There are differences with placement. Where are you going to place these on your roofs? Where are they going to be oriented? Depending on if you're orienting north, it's going to be terrible. But if you're orienting south, it's going to be a lot better in terms of how much energy you get from the panels. And then there are smaller differences like per panel inverters or even optimizers that will make better use of the panels that you do have. So that's a quick overview. I want to show you some pictures. These are solar panels around Green Meadow. So somebody asked in the pre-webinar questions, can you put solar panels on a flat roof? The answer is yeah, absolutely. So there are a couple of ways. If you can see in the middle picture, if you're lucky enough to have a southwest facing roof, you just lie them on flat, you get a lot of power that way. But if you have a flat roof, the nice thing is it doesn't matter because you can make the panels face wherever you want. So although I guess it helps to, in some cases you want to put on these rails and the rails need to go perpendicular to the beams. But anyway, that you can face them in different directions on a flat roof. And so you'll see this here. Some rules of thumb to keep in mind. So a panel costs around $1,000, a little bit more, but you can think of that as an initial rule of thumb. And 3 panels gets you a kilowatt. So, and you get maybe 4 hours of sunlight a day. These are, so let's go through an example. If you have 15 panels, you'll get 5 kilowatts. If you get 4 hours of sun, that gives you 20 kilowatt hours a day. So if you guys are, if your electric bill is around 600 kilowatt hours a month, which is average for Palo Alto, 15 panels would cover your use, more or less. But again, you know, you may want to keep in mind your future use. So if you are electrifying, and in particular, if you're, you know, you could size it for your car if you have an EV, you could size it for your space heating if you're going to do that. So again, there's this terrific link for Palo Alto that lets you estimate how your EV would sort out, depending on what you're looking for and how much it would cost and what your options are. I want to say a little bit about solar reimbursement because it's interesting how Palo Alto does this. Some utilities will pay people back. So if you have too much solar and you're exporting it, then the utility has to pays you retail rate for that solar. And that's not really fair because the utility is getting ripped off in that case because the utility would normally pay wholesale. So what Palo Alto has to do is pay the avoided costs. So they pay the wholesale rate plus a little bit more. So for transmission and distribution losses and things like that. That rate varies, the reimbursement rate. It started off around 7.5 cents a kilowatt hour. Now it's about 10 cents because the cost of transmission has gone up. So it's something just to be aware of. Some solar is less profitable, or here in the city of Palo Alto, partly because our electricity is cheap to begin with, and partly because we don't reimburse so much. So it takes us longer to pay off in Palo Alto. I wanted to add a note about batteries. Okay, so batteries add resilience. You're not going to have energy during an outage unless you have a battery. They're also good for the grid, so you can use them if we have time of use rates. You can take your midday solar, which is really cheap and worth almost nothing, and use it in the evening when it's worth a lot. So you can sort of arbitrage your own little energy there and use it when you need it. So when Palo Alto does roll out time of use rates, I think we're going to get smart meters in about 2 years, then it will even save you money that way through the time of use stuff. Batteries are expensive. So, you know, some of you may be thinking, do I want a big solar system? Or maybe I want a smaller solar system and a small battery. These are good questions, and it depends, I think, on how much you value the resilience and how, you know, maybe you think battery prices are going to drop. So maybe you just want to be battery ready. Good things to think about. I do want to talk about power outages for a second. We got a lot of questions about that in the webinar survey. And I don't think they're as daunting as people may think. So let me switch to that. All right, so we are all familiar with power outages. They happen pretty much, it seems like they happen all the time. They don't really, but you know, a squirrel chews a wire, or a mylar balloon hits a cable, or a backhoe takes down I don't even know what these backhoes are doing, but it's always a backhoe. So these outages last 1 to 6 hours, and they're unpredictable, and they rarely go beyond that. I mean, pretty much never. Sometimes people are worried about rolling outages. We alarmingly had a few of those last year. They should never happen. You know, when that happens, the state has just done a major, major screw up. But anyway, if they do happen, by design, they're 1 to 2 hours. So it's a lot nicer because we know what to expect. So the real worry, in my point of view, are these 12+ hour outages. They're very rare here. I think the last one was 15 years ago, and it was a plane crash in East Palo Alto or something, took down all 3 of our transmission lines. PG&E power shutoffs, though, are a worry. They don't hit in our area, but in the less crowded areas, the more rural areas, they're a concern. But here, honestly, I think people are somewhat misguided to worry so much about outages. So if you think about it, you have a 4-hour outage, your hot water is not going to get cold. Your house is not going to get freezing or boiling. You're not going to be able to do the laundry, like who cares, right? Celebrate. So your lights will go out, but we're used to that. You probably have a backup for your wireless because that's hard to live without. So you're not going to be able to cook. I mean, seems okay. You could get a propane stove, or you could get a battery. You can get a home battery. They're just an expensive solution to what may not, in reality, be that big of a problem. Just out of interest, the city is planning for a redundant transmission line into the city. They're thinking 2026. It hasn't been approved yet, but they're definitely looking at it pretty seriously. So if there is another plane crash, it still won't be a big problem. Let's hope that doesn't happen, though. Okay, so I think that's all that I want to say about solar. And again, we may have time in the Q&A for more questions on this stuff. So now we're going to switch over to John, and we're going to talk about some heating. So first, I want to give an overview and then pick John's brain about a whole lot of things. This is not an Eichler, right? We don't have crawl spaces. We don't have attics. But nevertheless, it is a house, and so there are some similarities. I just want to give an overview. What you can see here is outside of the house is a heat pump. And basically, it works somewhat like a big fan in that it takes a lot of air from the outside, and it extracts either the heat or the cold, depending on what it's turned on to do, with a refrigerant. And then it compresses that and sends that either really hot or really cold into the house. And that line, that heating or that cooling, can go many places. So one place it can go is to your radiant. So if it's going to your radiant heating, there's a little tank, and it heats up the water there, and that water goes out to your radiant. Or it could go to these what's called fan coil units that are either on your wall or on your ceiling, or they're standalone on the floor, and those can either heat or cool a specific room. And also, I think these can also heat up a hot water tank, and that can be used for hot water, although I have some questions for John about that. So anyway, this is the overall picture of what these things look like. This is courtesy of Space Pack, by the way. All right, so now, John, I have a million questions for you. So first, I want to show, people should see, these are pictures of heat pumps in actual houses, and you can see there's a variety. There's a company called Space Pack that makes them in the lower left and the upper right. There's a company called Chiltrix. You can see those in the middle here. There's a company called Sandon that makes them in the bottom right. Those are a little bit different. They use a different refrigerant. I don't even know what the one on the upper left is. So, John, maybe you could talk a bit about how people know if they need one or two of these things, and what affects the size of your heating needs. How can people think about that?
Well, the selection of the heat pump depends on, for heating and cooling, depends on the heat gain and heat loss of the house. So I think it was Dennis or Tony was talking about, I think it's Tony, about coming over and trying to help figure out how to make the house more comfortable. And it's really important, in order for these heat pumps to work effectively, is the house to be well insulated and the windows probably upgraded, because these things are relatively low output compared to the boilers that these Eichlers are accustomed to. So a typical Space Pack heat pump is called 5 tons, and that's like 60,000 BTUs on a warm day. And it's less than that when it's, let's say, 30 degrees outside. Maybe it's 50,000 BTUs. So unlike a boiler, which can provide the same amount of BTUs year round, these heat pumps are ambient air driven. So at the same time when we need more energy in the house, it's also the coldest time of the year. So we have to size it for the worst case scenario. And sometimes we will use a backup element type system to supplement it, but preferably without it. So we get take advantage of the high performance of these heat pumps, which is anywhere between 2.5 to almost 5 COPs. And then as far as these various units, when I take a look at the efficiencies of these things, I only look at the COPs as a general rule of thumb. I really look at the amp draw and how many BTUs I get out of it. I think amp draw is way more important than the COPs, which sometimes can be manipulated. So, like the Chiltrex system, around 30,000 BTUs, it gives you, it's about 13 full load amps. So that fits with a 20 amp breaker with 240 volt single phase. And as far as I know, some of you guys maybe correct me, but all residential homes have 240 volt single phase coming in from the street to that home. And then it's split from there to 120 volts to your other appliances. So we start off with 240 and we just have to move it from that location to the outside heat pump. If the less energy the house needs, the more efficient we can make these heat pumps run. So I do strongly recommend that the houses get their insulation and the windows upgraded so that we can use this technology. Because we can't, a 300,000 BTU heat pump is monstrously expensive. I'm not kidding when I'm going to say it's probably around $40,000 for that type of size of unit, and you need 3-phase. So let's see. Sherry, any other questions?
Oh yeah. Sorry. I didn't even know they would make a 300,000 BTU heat pump. I didn't know
As big as you want.
Yeah. Okay. So one question: taking a normal size heat pump, people worry a bit about where to put these, and there are 2 reasons for worrying about where to put them. One of them is Eichlers often don't have big side yards, maybe, and we have setbacks. So you can't put them in the setback, and the setback is sometimes 6 feet, but it could be more if you have a slightly bigger lot. And then these things are maybe 1.5 feet wide, and they also can't be right up against the wall. They have to be 1.5 feet away from the wall. So one thing is placement, and then one thing is noise. So I've seen stand-ins are maybe 40, but the big space packs are maybe almost 60 decibels. So can you talk a bit about placement? Are there any tricks to placement and noise? Anything to say about that, the sound of these things?
Yeah. So if we take the Chiltrex, for example, it needs like 14 inches behind it and 40 inches in front of it so that the air can come in through the back end and then go out through the front. It needs to have that air movement in order for it to extract the energy where they're heating for cooling. And the sound that, at least on these high-performing heat pumps that modulate, is really just the air. The compressors are very quiet. So the placement could be on a roof, it could be on a deck. The Chiltrex is at high is only 49 dBs, and the bigger one that comes out will be around 52 on high. It also has an advantage where it can actually be, you can program it to derate the unit a little bit, say make the fan speed just a little bit slower, and in many cases without affecting the performance, just slowing down the fan speed. You can program that. And you can also program the compressor too to make everything a little bit quieter. And I'm not aware of anybody else that has that ability to tune the unit to the site as much as possible. And it's mostly about the air from what I've seen. One one customer cheated on the space, like had 8 inches behind the unit. And I went out to the job site and literally turned the fan speed down 15%, and the sound issue was gone. And before that, it was a problem. And it has to have the space, otherwise it doesn't work. And where to place it, there are distances from property lines that have to be adhered to, and I kind of wonder if the roof might be an option for a heat pump like this if there simply is no place else to put it.
What happens if I think in a lot of Eichlers, the boiler's in a utility closet, which is in the garage, kind of on the side of the house. And there's room in the back of the house, but then you have a big distance between the pump and the closet or whatever. Is that okay? Does the heat pump have to be near where say the radiant boiler is?
Performance-wise, it is best to have it as close as possible. You can run like in some of these units, like the Chiltrex, you can put a second pump on it to make up for the distance, because we're trying to maintain around a 10-degree delta T, the temperature of what goes out of the unit and what comes back. And so we might have to increase the size of the pipe going between the 2 points, and then maybe add a second pump to make it up so it can actually achieve the tight temperature differential. With boilers, we're usually dealing with 20 or 25-degree temperature difference. With these heat pumps, we have to deal with a much tighter delta T, around 10.
Okay, that makes sense. One of the things I did ask about putting these on the roof, and the response was that vibration can be a concern, and so you can do it. That the city allows you to do it, but you'd want to really isolate the heat pump so it wouldn't vibrate the whole house, and put it over the right beams and stuff like that.
Well, it is roughly 350, 400 pounds. The sound, the vibration is going to come from the fan spinning on the modulating type units, and in a lot of cases you won't have that very often unless, but you will see it when you're doing domestic hot water. If you do domestic hot water, if it's space heating, it's going to be moving up and down just to match the heat load or heat gain of the house. It's often at like half capacity, just to maintaining what the house needs if it's sized properly.
Okay. And then final question on this slide is a little bit about cost. So what does, I don't know what a typical setup would be for an Eichler, but my guess it's either a big space pack or 2 smaller Chiltrexes, or it could be a small Chiltrex and then a mini split somewhere to help a little bit. Do you have a sense of what this would cost an Eichler owner to do this?
I can say that, well, I've been looking at some of these homes that are, let's say, 1,000 to 1,200 square feet. They're ADUs, but the contractors have told me when they put in domestic hot water heating, and space heating only, not air conditioning, radiant floor. This is a new installation. It's around $20,000. And I think it can be more than that too. I think for a bigger house, it's going to be, say, 25,000. And if the space pack system, it's going to, be more because it's a bigger unit. But
okay, so that's good to know. All right, I want to move on to the in-house components of this now, which are kind of cool looking. So they can go on the ceiling, as you can see here, freestanding, on the wall, low wall, high wall. So one question about these is, if you have your heat pump plugged into your radiant, so you're getting radiant heat, can you also add one of these to a room to get the heating and the cooling?
absolutely. if you're going to have a hybrid system as in terms of having a radiant floor heating system, to get the cooling, we really need this added to it. And it's also would be, if you know what your boiler is set for, like 130, 140 degrees or higher, I can, or 180, I already know that a heat pump is not going to be able to heat your house. So because we have to consider the hot water from the heat pump could be 120 degrees or less in general for it to operate efficiently. And then it might bump up to 130, 140 degrees due to domestic hot water. But it's a temporary thing. So, but for hydronic heating, usually we design it between 110 and 120 degrees. And so in order for the radiant floor system to work, we need to add more surface area by, a fan coil is probably the most efficient use of space. And these surface mounted ones certainly can be a way to go. If you're doing a major remodel, if you can insert it inside of a wall, we have units like that as well. Now, cooling is a whole nother animal. I mean, heating is one thing, and then cooling is still something else, because we have condensation is our biggest issue. And that's why we don't put radiant cooling in floors very often, because we cannot afford to have the floor temperature to say come to the point of condensation. A normal house that could be or temperature, surface temperature, 55 degrees or less, we could get moisture, and that can damage furniture, floors, and people could slip. So we if we do radiant in the floor, we want to make sure that the water temperature going in the floor is 55 degrees or higher, but that means it's harder to condition that space under those temperatures. There are other ways of radiant cooling, and that's in the ceiling perhaps, but the fan coil is probably the way to go, because and we can radiant heat with the radiant floor, and then we can cool with the fan convector, and actually get supplemental heating out of that spot as well. And then we can, we can divide it up into the house and keep the people comfortable.
Okay, so they do mix and match with Radiant. In fact, you recommend it because they provide the cooling and maybe also a little bit of spot heating. One question I had is, do they mix and match vendors? So if you have a Space Pack heat pump, can you use the Chiltrek in-house units, or is it all just everything has to go from one vendor?
You can mix and match it. As far as we're concerned, as an industry, it's just water moving through it. The area where it can be some issue is in the controls area. If there's some things work better under certain controls, but by and large, we can usually figure out how to make it all these things work together. We have a control system that should be able to work with almost anybody's system, unless you have a home automation system. That's another ball of wax. Or a building management system. They would have to supply their own sensors for that, and supply 0 to 10 to some of these fan coils, and send a signal to the heat pumps. I mean, there's a way of doing it. That does take a little bit of thought to make sure everything does work together, but fundamentally, it's just all about moving cold and hot water into the appropriate location, and then the controls take it from there.
Okay, that makes sense. Thanks. Okay, so one last batch of questions, and then you're not totally done, but then I'm going to ask Olivier to talk a bit about what he's done with his house. But so the last batch of questions is going to be about hot water. So as you mentioned, radiant heat is maybe 80 degrees, but hot water in our hot water tanks is about 120. And so the question is, do these get hot water hot enough? A lot of contractors do not recommend them for hot water. So what is your experience?
Okay, yeah, so we've had to learn how to do this properly as an industry as far as doing domestic hot water from a heat pump. the Chiltrex unit does have, this is a case where you do have to match the Chiltrex to its indirect water heater. It's especially designed for that unit and with large water capacity, very low pressure drop, and a massive amount of heat exchanger. The other types of heat pumps that I've seen out there, like I think the SpacePack has just recently, over the last month and a half, figured out how to do domestic hot water in the controls. What makes it inside the control logic, what has to happen when there is a call for domestic hot water is the heat pump has to go to a higher temperature. So it leaves the hydronic radiant heat temperature and goes to a higher temperature temporarily while there's a hot water demand. So, and that's the key feature that these heat pump manufacturers have to be able to supply in order to do domestic hot water heating. Like with SpacePack and AirMech, and I think the other ones, we have to use a flat plate exchanger and two pumps and a Chiltrex, just the indirect water heater and the pump that's internal to the heat pump under most circumstances, unless there's a great distance between the heat pump and the tank.
Okay, so it's getting there, you're saying. It has been a problem, but it might be getting addressed now. Although you can't, I guess what you're saying is the heat pump can't do the floor and the tank at the same time. It does one and then it does the other.
So like in the case of the Chiltrex, when there's a call for domestic hot water, there's a demand. It will go to heat pump and go to like 131 or 133 degrees to satisfy or prioritize, and it leaves the space heating or cooling for a certain period of time, which is about 15 minutes. If it cannot keep up, this is when normally we would have a backup element, and it would engage that element to take over, and it'll go back to space heating and cooling. This is the only ones that I know of that have this kind of logic. Otherwise, it might get stuck on space domestic hot water heating. Another thing that goes on with this type of system is that when it does go to domestic hot water heating and leaves a hydronic heating, the buffer tank, which is maybe around 20 to 25 gallons, that still has hot water in it. So while it has been diverted for several minutes, there's still heat left, or air conditioning left in the buffer tank to satisfy temporarily the space heating or cooling load. So because of the buffer tank, if it's radiant, we're not going to feel anything. But if it's fan coil, we might feel it, but maybe after 10 or 15 minutes.
Okay, that makes sense. So that kind of gets to my next question, which is, in the summer, can you heat your hot water and cool the air at the same time? So I think you said that works. So if you have a fan coil unit and you're telling it, I want the house to be cooler, and you've got your hot water tank and you're telling it, I want the hot water to be hotter, can it heat and cool? It sounds like it toggles between them, maybe?
Yeah, it does toggle to them. We don't have a de-superheaters at the moment, which is in the evolution of these heat pumps. There will be, when it's in air conditioning, we should have someday a de-superheater, which makes free hot water. It just makes hot, instead of rejecting the heat into the air, we can heat hot water with it, and we have a holding tank for it to go to. But it only works when it's in air conditioning mode.
Yeah, that makes sense. Instead of throwing it out.
It's been talked about, and I thought I'd have it available today, but it's going to be another year or two before I actually do see it.
Okay. Final question is, I think some people are interested in adding one of these integrated heat pump water heaters now, the kind that Scott was talking about, these, $4,000 installed, and then later adding one of the heat pumps for space heat, because they're not sure, they don't want to invest in the full space heating system now. Is that patently a bad idea, or does that just seem like a fine thing to do?
Well, can I talk about my struggles with the heat pump water heaters?
Yeah, go ahead.
Well, I just want to make this clear to our customers, is that that the heat pump water heater only makes on most, they all come from the same plant in China. And so I can say categorically, they're all the same. So, that they only make on low speed around 3,800 BTUs an hour. And on high speed, like 5,500 BTUs an hour. So, when we're used to having a 30,000 or 40,000 BTU water heater, this is a drop in the bucket. And I did a little calculation last night, or was it over the weekend? If at 3,800 BTUs an hour, it takes like 6.7 hours to move it from 60 degrees to 120 degrees. So and I don't remember what it is at 5.5, 5,500 BTUs an hour, but it's a few hours less. But so what we're dealing with is for the end user is a change in their expectation of how quickly they can have hot water back, unless we go to the backup element, which is around anywhere between 13 and almost 16,000 BTUs, whether it's 3.8 kW or 4.5 kW element. If we combine that with the 5.5, then we're up to 20,000 or so BTUs, which is closer to what people's expectations are of a 30,000 BTU, 70% efficient water heater. So that's still over an hour to heat it back up. So I just want people to understand that the heat pump tank type does take longer. That's why it's really important to have a larger tank so that you don't run out of hot water, and we're not pulling it all the way from 60 degrees back up to 120. We maybe shape it down to 90 degrees and then warm it back up to 120. So have a bigger tank does definitely help to try to maintain people's expectations for hot water. So that gets me back to your question. So if you have a outdoor heat pump unit, it has a heck of a lot more horsepower to deliver the BTUs that people are going to expect. So like a Chiltrex unit, which puts out around 30,000 BTUs, effectively, if I convert that, that's an output. If I convert that into input versus a 30,000 BTU tank type gas-fired water heater, that's 45,000 BTUs. So that's one way of looking at how to equalize that. So yeah, I think it's closer to what people might expect. And one thing that I have to always tell people is these electric water heaters are not tankless water heaters. They're 200,000 BTUs. We cannot compete with an endless supply of hot water. Our customers need to be aware that the heat recovery on our electric water heating systems is slower.
Yeah, so I think that's right. I think it is important to size your heat pump water heater properly, and maybe get the mixing valve so that you can heat it even higher so that you don't run out. Because it's like if you run out of quote gas in an EV, you're in a worse situation than if you ran out of gas in a car. So
if you are moving it all the way to 140 degrees, that is element. Not our little heat pump part is not getting it to that temperature. We're using the element part to pop it to that temperature. We can't do it with the heat pump.
Right, and then it's less efficient. Yeah.
This COPs of we're getting kind of close to element even with a heat pump, less than 2. Anyway, I just had to get that off my chest. So I do.
Yeah, I know.
I do.
No,
it's important for people to understand, what are they getting, and it's some people. If you don't have a big house and don't have a lot of people in the house, it's okay. If I deal with the complaints. So
yeah. What I've heard is that baths are a big problem. I did talk to somebody who's got a bunch of kids, and her 80-gallon one is completely fine. They don't even notice it. They had 5 guests over, and then they had to be careful. But they don't take a lot of baths. They take showers, and the showers are fine, and so they don't really even notice it. But I do think it makes sense to think it through, because if you don't think it through, it's not going to work. Yeah.
Generally speaking, as as a designer, we figure that 75% of the water content of your tank is actually usable. So if it's at 120 degrees and it's an 80-gallon tank, that's really only 60 gallons. So that how big is the tub? And you have to size the tank according to the largest demand, which is going to be the tub. So maybe you might have to have a bigger 80 gallon in a lot of cases covers a lot of our issues. The smaller, we could run out of hot water. Then there's always the 119 gallon size as well.
Yeah. Okay, so let's go. I want to, we'll come back to you, John, because I have more questions, but I want to hear from Olivier. So Olivier has worked on his own space heating, but he's using air to air. So I just want him to tell a little bit. Olivier, are you there?
Yep. Yes.
Okay.
Can you already hear me? All right. Cool. So yeah, so that's maybe a slightly different tack. Like I did try to, I was looking into like air to water heat pump, basically what has been described tonight. But that was like many years ago, and really there was not really viable options in the US that I could see, at least not affordable for domestic purposes. So by the way, share like, if I was hoping to share a couple pictures, I don't know if you can maybe enable screen sharing.
Let me see. Thought you could do that already.
Anyway, I'll try in a sec. So I can quickly go over like a bit like Dennis. I went through the whole like it would be good to get an EV, then solar. The next, upgrading the panel, because we had a 60 amp Zinsco, so a 60 amp Zinsco, which was a bit scary. So that's one of those snowball thing where like we're redoing some of the wiring, trying to add the wiring for the EV charger. We redid the roof as well because wiring goes up there. Anyway, I'm glad this is all done. The next bit that was left was space heating and water heating. So it seemed like water heating, we pretty much got sorted out tonight. For space heating, I did maybe have an approach that's a bit unusual in the sense that we want to also have a AC. So I was wondering if just getting basically a mini split, which is air to air heat pump, would work for that. So installers were usually adamant that for this to work, I needed a humongous system. And I actually have one neighbor that did install like one of those mini splits in pretty much each room. So I think it has 5 or 6 heads, 2 outdoor units for a really big system. And he came to the conclusion that it's basically too much. I was hoping to control it remotely to heat up or cool down ahead of time. He told me, yeah, no, I don't even use that because it's especially for cooling is almost too quick. For cost reasons, we went with a single heat pump, so one head only in the living room. So I'm not. Yeah, unfortunately, sorry, Sherry, I still cannot share. And
I thought that if I stopped sharing that you would be able to. Let me just.
No, it tells me that.
Oh, hold on. Oh, wait, hold on 1 second.
The host is disabled screen sharing.
Okay, now how about now? Can you share?
Yes. Okay. So let's try that. So yeah, so that was just the solar. So yeah, there's also one thing quickly, but we also have solar hot water, which does need backup in winter like now, because yeah, it doesn't heat up all the water we need every single day. Although it does provide more than enough in summer. So yeah, we're probably gonna put like a heat pump water heater to supplement that thing. Right now it's gas, and that's pretty much the only thing that prevents us from just cutting the gas line off completely. So anyway, so that's quickly, that's the inside. So that's this single head, mini split. It's installed like in the like across like living room, kitchen. We actually have opened the wall, so it's almost like one large area. This whole space. That's that heat pump is actually, it does do a great job at cooling, but it is optimized for heating. It's one of those Mitsubishi Hyperheat series. And it seems to have actually performed better than I expected in both terms of how much heat it does provide. So it is rated for mean, John is probably gonna, I don't know, cringe at this point. It's 5 kilowatt thermal, so it's like 18,000 BTU, so 1.5 ton. That's the rating of this thing, which should not, so it's basically almost a tenth of the boiler it replaces. It does actually ramp up quite a bit more, apparently, to probably almost twice that setting, as long as it's not too cold outside. So that particular unit can go down to, I don't know, minus 25 Celsius, or like, I don't know, insanely cold, like he will never see anything so cold here. So it's apparently more than plenty when it comes to temperature rating. So yeah, for those who are wondering a bit like, where does this thing go? So this is the side yard. So yes, indeed, there is this those setback requirements. Apparently, we're just okay there. But that's that gives you an illustration of where those things can possibly be squeezed in. So anyway, so far this winter, this thing, oops, where is it? Has managed to keep our cellulose plenty warm. The boiler has not kicked in at all. But one of the drawback is that obviously it heats up this area mostly. So the bedrooms do get a bit cooler, which is totally fine for us, but may not be acceptable for some other people. So, I mean, and also, yeah, that also means that we typically leave the doors open during the day. So that's why the single head can provide enough heat to the rest of the house. But it would probably not replace a whole house heating system for other people.
How much would you say this cost you? So you have the one heat pump and the one head. So do you remember what about that cost?
So yeah, so I mean, so this particular one was a bit under, like between $6,000 and $7,000 installed. The hardware itself is only $2,500, I think, or maybe maybe not even. I don't think it's, I mean, given the installation cost, I was recommended cheaper units, but frankly, it seems a bit ridiculous to go with low-end brands there because of like such high labor costs.
Yeah, so I think this is an interesting approach. Sometimes people are cowed by getting the Radiant working and all of this stuff. And one idea is you put in a mini split and you see how far that takes you. And just doing that, suddenly you're using so much less of your gas boiler for Radiant, right? Yeah, go ahead.
So yeah, that was the approach, and we did have that option because Radiant still works. So it's not, I mean, it was not installed as a replacement, even though that's actually what it does now.
Yeah, that's interesting. John, do you have anything you want to add since you're here? I think I can't see if he's nodding.
Okay, right, I unmuted myself there. If you use heat pumps for the radiant floor heating, I want to just make sure that everybody knows that you need to clean out the tubes and then put conditioner in there. You could reuse the floor. However, you have to take into account that the heat capacity of the heat pump, and then always clean out the tubes. Otherwise, it will get destroyed because of the gunk inside there. No, this is I thought a simple approach. The mini split system. It obviously is undersized, but you might have to have more than, because it uses one head per outside unit. So you might have to have 2 or 3 of those units if you really want to condition the house properly. Would that be right, Oliver? Would you think?
Yeah, so this, I mean, indeed, I mean, that like cold climate rated heat pump seems to be quite good at heating up things, but indeed, there's a single head, so it's pretty localized. So people will feel there's a, I don't know, difference in temperature throughout the house if there's only a single head. It is indeed, like, I mean, undersized, although I did, I mean, the reason I picked this one was I basically took the total of all the gas we've used, I don't know, for over the past, I don't know, many winters. And well, assume that the current heating system was about 70% efficient, which is probably even less than that. And install a heat pump that would cover basically just that. So it would not cover like worst cases if it's particularly cold some days, probably, even though it hasn't bothered us so far. But yeah, there's probably very little margin.
So one advantage of a hydronic heat pump versus the split system here is you can have multiple heads and have probably a more evenly dispersed energy throughout the house. So this, what the customer just needs to take into account, a more localized versus a single unit in most cases with multiple heads for distribution.
Yep. So I think for what the difference John is here referring to is like the system that's I show here is like air to air, like meaning there's refrigerant moving between the heat pump that's outside and the unit indoor. And typically those are 1-to-1. There's one compressor outside for one head, although their system was with more. It does not scale well in the sense that each unit probably costs like, I don't know, $5,000 installed. So doing that throughout the whole house, like a neighbor has done, that was a $25,000 project. I don't know how that compares with a system that just moves water between I mean, at this point, those are hair handlers, I guess you would call that, John.
Fan coils are, in a sense, they make heads that look just like that. That's hydronic too, so you can have the same look as a VRF system, like this refrigerant system, but hydronically, same look. But you can have multiple heads for just moving water around in piping.
Okay, but you would think there's a cost advantage of going like moving water around instead of refrigerant?
I think for smaller applications, I think the VRF definitely has an advantage. If it's a broader area, then I think the shift moves to the water side.
Okay, so I want to go back to, oh, actually, we have one question for you, Olivier. So how is the sound of this mini split that you have outside in your side yard? Do you...
it is actually spooky quite. So unless, I mean, it has variable speed. So most of the time it's running at a speed that I cannot, I mean, unless I go next to it or I look at the tree right next to it to see if the leaves are moving, I'm not able to tell whether it's on or not if I'm like standing a couple of meters from it. If it does ramp up to, I don't know, like full blast, then it's a bit more, but it's definitely a lot quieter than any air conditioner I've heard before. So I think like modern units are so-called like inverter based, so they can ramp up and down. It seems like they're built in a way that the compressor is partly quiet compared to like old school, like square-ish units. So yeah, by the way, it's the room that's behind there is the master bedroom, and yeah, we can't really hear it from there, even though the window is right next to it, obviously.
Yeah, I highly recommend using modulating inverter duty type heat pumps. It definitely makes a big difference. It's really just the air moving around, and because the equipment is now so quiet.
Okay, so Olivier, do you have can you unshare?
Oh yeah, sure, yes.
Can go back. Okay, let me see if I can go back to presenting. Let's try this. All right, so can you see this hot water slide now?
Yes, we can.
Hopefully. Okay. So these, John, if you have time, I want to ask you maybe 1 or 2 questions, and then we might wrap this thing up because we're getting a little short on time. So first question is, I'm not going to ask all of these, it's a lot, but what are common mistakes that people make with their hydronic heating? How would you avoid them?
Well, since we're talking about Eichler homes, I guess the first question is they already have a hydronic heating system. How is it working? Is it leaking? Or is it working? What kind of pressure can it still withstand? I mean, one of the tricks to keep it running is to keep lowering the water pressure. And then there's also anti-leak things. So the question is, is your radiant floor heating system still working? And then the next one is if it's not, then, you know, or if you want to go another direction and add cooling, then we need to look at fan coils, or maybe fan coils is probably the best way, because now we're just using small pipes, you know, probably 3/4 inch pipes moving around the house. The mistakes was we had to have a buffer tank. So and then the correctly sizing between the outside unit to the inside unit, and then the distance, closer the better. And there's just little things like that extra pump issue that helps make sure we can still supply the heating and cooling that people want. For cooling, it's all really about the condensate, how to deal with that, so we can direct it to a drain or to the outside. And in some cases, add a little condensate pump at the fan coil unit. That's where the water will collect, or an air handler, or anything that's transmitting the cooling. Condensate can collect at that location. We have to get rid of it. That's the most common mistake. But should I go to the next question?
I was muted. So it sounds like the fan coil units need access to some drainage. It sounds like people may not size these properly. It sounds like they may try to get if the radiant is not working well, putting a heat pump on it is not going to help. So if your radiant's not working, just go to the fan coil units for heating as well. And then make sure you size it properly. Look at how many BTUs you're getting from your boiler. Get something that's kind of comparable, or, you know, understand what you're doing. I think maybe the next question will be the last one. Is the tech getting better? You know, in what way? And does it make sense to wait a few years and do other things first? Or, you know, what would you say are the big improvements coming down the pike?
Well, the technology that's changing things really is the modulation. And let's see, we were the Daikin Altherma rep from almost 10 years ago. So we pioneered this technology, but the efficiencies, and they've gotten quieter. The technology is better than it was just a few years ago. And they're coming out with better refrigerants, like an R32. The Chiltrex is coming out with that for their larger unit in a few months. So that's less global warming factor with R32 versus the R410. I think as far as the next level of technology, it probably is that and better refrigerants. There are controls that are getting better. I think we're pretty much there. It's just we don't really have a really high temperature heat pump to just fit into these Eichler homes. The technology that can do it requires 3-phase power, not 240 single phase. But if you're so lucky to have that kind of power, well, yeah, we can get you a 180-degree heat pump.
Well, doesn't Sandin use CO2 and that gets pretty hot?
Right, so let me clarify. The Sandin uses CO2, which is really good for domestic hot water. Can also generate high temperatures up to 170 degrees. The problem with this technology is it doesn't like warm return temperatures. So like when we do hydronic heating, you know, like a 20 or 30 degree delta, it'll short cycle a Sandin type unit, and it will try to kill itself, and then operate very inefficiently, less than 2. You know, a little bit more than 1 COP, but less than 2 when it has close returns. It also operates at like 2,000 psi pressure, so components don't tend to last as long with that technology. Other refrigerant systems are roughly around 500 psi, and it's been operating like that for decades. It's the traditional refrigerant systems. But if you're just doing domestic hot water heating, Sandin is really, really good at that.
For the space heating, do you have a favorite brand? Airmac, Arctic, Chiltrex, Space Pack, or depends.
Well, my favorite brand is Chiltrex, and it has many other features that I have not talked about. But it's definitely has been very reliable. Has a lot of little things that just are not taken into account by the other units. And that separately, I can do a presentation on going over all of that. But a Space Pack is the new one to the marketplace with modulation. So far, it's been working fairly well. Aramec actually just came out with a modulating unit like within the last month. So I don't really have any experience with their modulating units. They've all been usually two-stage type units. And so they are noisier than say the Chiltrex, and the Space Pack's a little bit noisier than Chiltrex.
Okay, we did get a question, what is the lifetime of these? So how long would you expect if you get, you know, 1 or 2 Chiltrex pumps and maybe 3 head units inside of the house? How long would you expect that to last?
Well, the head type units, it's really just a fan, and those things ought to last 15 or 20 years for those things. There's not a whole lot to them. Then there's the heat pump outside. We've sold almost 200 units of the Chiltrex in the last 2.5 years. We've had like 3 or 4 boards go out, and maybe 4 flow switches. And we figured out what was wrong with the flow switches, and that was the original batch didn't have silicone in a certain spot, and if the unit went to cooling, condensation was collecting on that electrical part of the switch. And so now we have that spot filled in with silicone and don't have that issue. On the control side, it can actually, we have to make sure that your power is good. So perhaps one thing we really want to have our systems last a really long time is have something that conditions the power before it goes to appliances like this. You know, surge protector at least.
Yeah, that makes sense.
They'll ask you a question, 15, 20 years, they should last a very long time.
Okay. I'm going to wrap up this webinar now. I think it was great. I really want to thank all of the panelists who participated. There was a lot of depth of knowledge, I feel like. If attendees want a copy of the presentation or a copy of the recording, please, we need your email. So if you email info@greenmeadow.org, or you happen to know one of the panelists, email them, we can get this information to you. Again, I think some of the takeaways here are, think ahead, you know, check the age of your gas appliances, look at your electric panel, do some efficiency work, and then take some small steps. And whether that small step is an integrated heat pump water heater or a mini split, to sort of just something to get your gas use down, or maybe you want to try one head in a heat pump, hydronic heat pump, and see how that goes. So I think there are a lot of options here. But please don't forget to email us if you would like a follow-up. What else? I think you're going to get a survey when you leave the Zoom, if I set that up right. There's some resources for you. Again, City of Palo Alto has some terrific resources. I want to thank the panelists again. You guys did a terrific job. Thank you for preparing and for being so thorough and answering your questions. All right, so we'll see you later. Thank you for attending, everybody.
Thank you very much.
All right, thanks.
Thank you, Chair.
Thanks everyone for attending.
All right, let me see.